Hey folks, Kevin here. Well, it's October 30th, 2019. I'm outside, and today I thought I'd share with you my thoughts on doing some calculations on slope and how that can be helpful on your homestead, on your permaculture site, when you're trying to control different resources that you have. So for example, with where we live in central New York, we live right in the snow belt. We get really heavy snow loads in Oswego, New York. So the pitch on a roof, which is a slope, is very important so that we don't have a roof collapse during heavy snow events. Another important aspect of knowing the slope or the pitch of your roof is if you know where you are geographically and you're facing your roof south, the pitch of the roof can enhance your ability to gather as much solar energy for your photovoltaic cells, your solar panels on your roof as well. So those are two key things when you're doing a building for how slope is important. If you're purchasing property and it's near waterfront, certainly your waste management or septic system, the slope of the property, if it's greater than 6% slope, there's a greater chance that you're going to have soil runoff, you're going to have soil erosion, you're going to have waste get into the well system or the lake or the canal or the river or whatever the body of water is. So being able to understand how the slope impacts your ability to influence other properties is also important. On your own property, you may say, geez, I want to have a garden here, but the slope goes in this direction, and I want it to go in this direction. How do you change that property so that you get proper soil orientation? You deal with the excessive rainfall that you get during the summer months when you're growing your gardens, so that you can have permanent raised beds and your crops don't get ruined as a result of heavy rainfalls. These are all important things for resilience. Certainly, as permaculturists or naturalists, soil erosion. We want to protect our property from losing very valuable soil. It takes time, energy, and money to build soil, so we want to do all we can to maintain that. We also want to deal with unpleasant spots on the property, boggy spots where it's too low in some areas, and we want to have drainage soil systems to control and route the water to locations that we want it to be. We may want to figure out how much fill we're going to need to fill in that low spot, so we need to know what the slopes are to the sides that actually create that low spot on the property as well. Now in permaculture, when we talk about slopes and we talk about swales, we're talking about putting swales on contour, so perpendicular to the slope of the property. So if the property comes down this way, we want to capture that water and runoff material by having the swale system going perpendicular to that, and that way we can slow, spread, and sink that water, recharge the aquifer, take care of our water needs elsewhere on our property, refill pond systems or dam systems as well. So those are all good reasons to understand slope on your property. So how do we calculate slope? There's a few ways of determining your slope. So one thing would be, what is slope? Slope is a change in elevation over a given distance. So when we look at a 612 pitch on a roof, we know that for every 12 inches horizontal run, there's a 6-inch, 50% of that length, a change in elevation. So a 612 pitch is like a 45-degree angle. But when we're talking about slopes of our property, we want to know what the slope is. Is it greater than 6%, where we really have to worry about soil erosion and other problems? So one of the ways of calculating our slope is we could use Google Earth. And when you go to Google Earth, you can look at your property. So by Google Earth, I know that corner of the property, our highest point, not actually our highest point, but the highest northeastern part of our property is at 450 feet elevation. And we know that there's The different places, it's just under 400 feet at our southwest corner of the property. So we have a 50-foot change in elevation. Now, it isn't like a simple flat line that goes right down there. There's undulations, there's higher spots and lower spots. So that's what we're going to do, is try and figure out what our goals are. So like over in this area here, I wanted this area to, which was an area that was very low. The change in elevation from one point, which is just behind me here, dropped 6 feet to the other spot. And since this is a lower spot more towards the western side of our property, the water would come down from all these other areas, come down into this area, and it would be useless for growing plants over in here. And I want to put a high tunnel, which is a non-heated greenhouse, as a form of season extension. So during those winter months, we can be harvesting food that is no longer growing and have food to eat all winter long, fresh greens, carrots, and a variety of different plant materials in this high tunnel. It extends our season, our growing season. Extends our harvesting season, let me put it that way. But we can't have it on a low part of the property. So what I did over here was first determined what is the change in elevation over the 100-foot long area that I want to look at. And I knew that I wanted the area to be at least 50 foot wide. So I knew that I had 100-foot long by 50-foot wide, and that's 5,000 square feet. But how much fill would I need down in there? Now this piece of area, actually there's hugelkultur pits underneath it. So what's a hugelkultur pit? Hugelkultur pit is when I take the excavator and I dig down from the surface of the ground and dig down 6 or 9 feet. And I deposit in there dead trees, stumps, branches, all of those materials, pack it down really well, then take some of the soil that I dug out of that hole and I fill it in. I usually save the topsoil and I'm going to use it in a different spot in the property. But if I needed fill in one of the excess roads, I take the gravel material that came out of there and fill in the excess road. If I want to screen some of the sand, I use some of that material elsewhere. So the main goal over in this area is sequestering carbon, taking those woody materials and burying them underneath the area. Then I needed, and that brings it up to about the level that it was before. I really don't get much of a change in elevation. So one of the things we can do is determine what our change in elevation is. So on Google Earth, I could see when I put the cursor over this point and then I put the cursor at 100 feet away, I know there's a change in of 6 feet. What are other ways that we can do that? Well, we can use a site level. So this is a site level that I picked up on Amazon. I think it was about 15 bucks. I'll put a link to it in the description below. This is a Johnson site level. And how this works is it basically has a lens through which you can look through, and there's a vertical bubble line like a level. So here's a bubble level here, here's another one here, and you want that bubble to be right dead center between those two lines in order for it to be level. And with this one, you want the bubble to be split by the lines when I'm looking through it. So as I'm looking through it, and whatever distance you're looking away, you can look at a spot on a tree, on a wall, whatever it is. Once you get that bubble split right in half by the center line. That way you know that this is absolutely level at the level of your eye. So it's important also to use a ruler, a tape measure, and see what the elevation of your eye is with the shoes that you're wearing. That's important. So today my eyeball is at 70 1/2 inches above the ground level where I'm standing. So if I were to shoot the distance down on a tree at the other end, I might go down and measure where we are down to ground level from that point and subtract the 70 1/2 inches from whatever number of inches that the height that I'm measuring on the tree down there. So that's one way of doing it. Now it doesn't take into account the little undulations. So there could be a gully in between and then that's a higher spot. But there's ways of dealing with that as well. So we can use a level, or we can use a board with a short level. The important thing is knowing what the run is, the length of the board or the length of the level, whatever it is, and you're measuring once you set this level. So let's say that this is a high point here, and we want to measure the difference between this low spot here and this high spot here. You'd measure from the top of the level down to the ground level, and you determine exactly what that difference is. So it's rise over run. The change in vertical or elevation over the length that it is. And that gives you your slope. So I hope you can hear me. There's tractor trailers going by. So the change in height from going over 100 feet. So I'm going to use my calculator here. So we have a 6 foot change in elevation over 100 feet divided by 100 ends up being 0.06 decimal point. You multiply that times 100 and you end up with a 6% slope. So that's what your slope is, 6%. And slopes greater than 6% or greater, there's more of a chance of soil erosion, losing nutrients off your property into another area, and or for mudslides or that sort of thing. When you get much higher, changes in elevation more than that, significantly more than that actually. So those are things to think about. That's a way of doing that calculation. So let's try and determine how much fill I need to bring into this area. So bring up my calculator again, zero it all out. So this is 100 feet long, so it's 100 feet long. Let's say it's going to be 50 foot wide because I want to have some space on one side of the high tunnel and space on the other side of the high tunnel before the drainage swale goes around it. So we'll say 100 feet by 50 feet ends up being 5,000 square feet. But we know that it's a 6 foot change in elevation at the other end, so let's multiply that times 6, and that ends up giving us, where's it equals, 30,000 cubic feet. But that's a rectangle. That would, by using 6 foot deep, we're calculating the volume of a total height of a whole rectangle as being 6 foot deep. We need to divide that by 2, and that gives us 15,000 cubic feet for the wedge, going from 0 point elevation to a minus 6 foot elevation. That's 100 foot wide by 100 foot long by 50 foot wide. So now we know that there's 15,000 cubic feet. We know that there's 27 cubic feet in every cubic yard, and that tells us we got 550 yards. You may use dump trucks or whatever it is, loads of materials, and know that you need 550 yards. I know my dump trailer takes about 6 yards in each load, so that means I need about 92 and a half dump trailer loads of wood chips over in this area in order to bring it up to this level. Now, of course, those wood chips are going to break down, they're going to compact, they're going to reduce in size. I'm going to have to do that multiple times, but if it were gravel, that would be a fairly accurate amount, estimate of what you'd need. So, quite simply, a slope is really the change in elevation over a determined length. Now, there's parts on the property where the slope is relatively steep, then it flattens out, and then it gets steep again. And that can be more challenging. So you may want to use your level or your sight gauge and only go so far at a time and see what the slope is over the first 25 feet, and then the next 50 feet, and then the next 30 feet. And what you would do is take each one of those determined slopes and add them up and divide by the number of measurements that you took. And that would give you the average slope over time. Or you could use something like Google Earth as well. So those are ways of dealing with it. I'm going to take you up to another part of the property, a place that I've been working on recently, and changing a slope. Okay, the camera is actually sitting on the edge of the driveway. Here's one of our pillars that go along the driveway edge. And previously I posted a video about the flood. We got 4 inches of rain in less than 3 hours, and certainly places get much more than that. And we exceeded our capacity of some of the swales, and so we had runoff that actually damaged some of the driveway. Now I've done some significant changes on the driveway as a result, maintaining a better crown and having these swale systems open up their passages, because one of the things that happens after me putting the system in, the soil really started building up over time. So I got over 1.5 feet of good soil being built up along the margins, which made more water go back into the driveway. So I've been doing a lot of work, calculating what are our slopes here and how do we control the amount of water going into these swales. Now, these swales here, as you can see, there's some trees behind me. There was another tree right here that I took out that was dead. But when I put these swales in, I didn't put them on contour the way most permaculturists would do. What I ended up doing was trying to direct my swales so I'd interrupt I didn't want to damage the roots of many of the trees on the property, so I cut the swales in so that the swales actually go deeper into the property, so the depth of the swales was much deeper. And so as a result, the pitch or the slope of the swale in some cases was pretty high, which made it more challenging to get in and mow, or to safely and comfortably walk on the lower side of the trees that we're harvesting. So I had fruit trees going right down in this area. So over here you may be able to see those white tree tubes. Those are all hazelnuts in all of those tree tubes there. I've got a couple of rows of those. And on the other side of that area is, recently I posted a video talking about transplanting many trees. And so that's over on the other side there. So I have areas where water had sort of settled in some low spots. Soil depth got super deep in those areas, at least 1.5 feet deep of soil, as a result of letting the grasses and the weeds grow so tall and only mowing that down about once or twice a year. And so the soil really grew up significantly, developed significantly. And then we had this area where we had the fruit trees being put. The soil wasn't increasing the same rate, and so the tree crowns were starting to get more water saturated, which really delayed them. So I decided to dig those up and raise those up above soil level, and create a more controlled pitch of the property, the slope of the property, so I could control precisely how much water is going to stay in the heavily wood chipped areas and how much would go into the swale systems. And I wanted to pay close attention to the slope of the swale, of the preceding slope going into a swale system, so that it'd be very safe to be able to work with. So that's what I've been doing this past couple of weeks. In between things is coming out here with Bumblebee, the mini excavator, digging out the high spots on this side of the swale, the part right behind my head. I should move over here. So it was higher down there at the other end, much higher, so I ended up digging out about 3.5 feet down, and then taking that material and filling in lower spots in other areas. It still needs more work to be done, but I wanted to show you this at this point before next spring when I get in here and things dry up more. It's still so important that the base of the swale is maintained level, and that's one of the blessings of having your output for the overflow of a swale system being above the base of the swale system. So that way we don't get sediment or roots working the way into your pipe, leaving, or your spillway, and plugging up the spillway. So my spillway pipe is actually above the level of the base of the swale, and that way I can use the base of the swale to collect soil for fertilizing or fertigating other areas on the property. So, and I'll talk more about that system in the future. So when I was cutting this system in, we had rain recently, So water stayed right in the very base of the swale, so I could make sure that as I was excavating along there and pulling out the extra soil from that area, that I was maintaining that level base of the swale. That water within the swale, even though it was just about 1.25 inches in there, it allowed me to maintain a really nice level line going all the way across there. Then all I had to do was take out all the little peaks that were just too high, take that material, move it to another area, and then spread it out some, and then go back again, measure my slope and see, how steep a slope is this? Is this a comfortable area to be working in and walking in? Because more of the food forest is going back over here after I get this all set. And I have to take into consideration, well, how much soil am I going to be building up for whatever I put in here, fruit or nut trees, whatever it is that's going over in this area, or berry bushes. Whatever it is, I need to pre-plan the change in elevation when I'm putting those systems in, and make sure that I don't create a back pooling system on that side of it, the uphill side. I don't want to have water sitting up against that system. So I hope this was somewhat helpful. Sharing with you how I'm using slope to determine how I'm using the calculations of slope to determine how I'm going to control the water flow on the property, prevent erosion, fill in low spots, use soil from areas that are too high, and move it into the low spots as well. So if you found this video of value, please give us a thumbs up, share it with your friends, and by all means, folks, have a great day. Bye-bye now.